This video, we're looking at the 2003 Chapter Math Counts Sprint Round, number 24. And in this problem, it's talking about two different cylinders who have the same volume. So the first thing we need to do is recognize that the volume of a cylinder is the area of the base, which is a circle, so that's pi r squared times the height. So for our narrow one, we have some value h here, and then they actually told you the radius of the narrow one, and that's 12 units. And so we're going to have a 12 there for the radius. So for the narrow one, we could say pi times 12 squared times h. And then for the smaller one, well, we don't know what the radius is. That's what we're trying to find, and so we're going to let that be r. But we do know something about this h, and it turns out that it's going to either be a third of the h of the narrow cylinder, or we could think of it actually better that that cylinder is h and this one is 3h. And so let's just redo our equation and realize that the volume of the narrow cylinder is pi 12 squared times 3h, and then the volume of this one is just going to be our pi r squared h. The great thing is the h's cancel, the pi cancel. You can divide both sides by h, you can divide both sides by pi, and that's going to leave you with 432 equals r squared. But if you'd have thought about it, you can actually think about this as 12 squared times 3. So when you take the square root of both sides, taking the square root of 12 squared is 12. So 432, 12 squared goes into it 3 times. So you could think about it as 144, square root of 144 times square root of 3, which gives you 12 square root of 3. So the radius must be 12 square root of 3. The other way you could do this, a problem like this where you're talking about ratios or things that have the same volume, you could think about the h of the small one being 1 and then the large one being 3, and then do the same math, and it'd work out exactly the same, but just using the h works out as well.